The quadratic formula. So the quadratic formula is basically a shortcut. It is completing the square, but it's a formula for doing so. And so actually what we're going to do here is generate that formula. So basically we obtain the quadratic formula by using completing the square to solve the general form of a quadratic equation. Ax squared plus bx plus c. So we're going to do this. It'll take us a little bit of work, but we'll get there. Okay, so the first thing we realise is we're trying to complete the square on the left-hand side, and we have a non-monic quadratic, so we must factor out the a before we do anything. So we're going to have a x squared plus b on a x plus c on a. Okay, so we've got no choice in the matter there. Now we're trying to complete the square inside the bracket, so we're going to have x squared plus b on a x. We need to figure out what to add and subtract in here to make a perfect square. And then we'll have plus c on a. Okay, so we wish to halve b on a, which gives us b on 2a, and square that. Okay, so now this here is our perfect square. So it is going to be x plus b on 2a squared. And then we've got minus b squared on 4a squared and plus c on a. So I'm going to collect those terms at the end together. So we need a common denominator, which will be 4a squared. Now we're going to multiply, we're going to collect those together first, sorry. So we've got x plus b on 2a all squared. Then we have, now be careful how you put this together. So we're going to have, I'm going to write it as plus negative b squared. Actually, what's the best way for me to do that? No. We'll leave it as minus, but you've just got to be careful how you write it when you put it together as one fraction. It has to be b squared minus 4ac, because this negative here applies to the whole fraction. So it's negative b squared plus 4ac. So it's 4a squared on the bottom there. Okay, so now if we multiply out by a to get rid of those big brackets around everything, so we're going to have a times x plus b on 2a squared minus b squared minus 4ac all over 4a. Okay, so we've completed the square, and so now we want to go on to solve. Okay, so we'll just start a new page. I've just carried that last line down. So we now wish to solve, so we're trying to isolate x, and while this is a very ugly expression, there's just a little x in here, so we just need to get that on its own. So I'm going to add this big fraction to both sides. So we're going to have a multiplied by x plus b on 2a squared equals b squared minus 4ac all over 4a. Then we're going to divide both sides by a. And in fact, we probably could have embarked on this solving a bit earlier, and we wouldn't have needed to expand out by the a few steps ago, and we would still have ended up here, but it doesn't really matter. So we've got b squared minus 4ac all over 4a squared. Okay, now we need to take the square root of both sides. So we're going to have x plus b on 2a. We're going to have the positive or negative square root of b squared minus 4ac all over 4a squared. Now that denominator we can take the square root of that, because the square root of 4a squared is 2a. So we're just going to have plus or minus square root of b squared minus 4ac all over 2a. Okay, so now we want to subtract b on 2a from both sides. I'm going to write it at the front. It's just the traditional way to do it. And we have a common denominator here, so we can write that as one big fraction. And there you have it. That's the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. It is an ugly looking formula. It's one you need to know. So just start, if you don't know it, learn it. It's not on the formula sheets that you get in your VCE examinations, and it is something you would be expected to know. So if you didn't learn it properly in year 10, you didn't learn it properly in year 11, you need to learn it properly now. Okay, so now we have our formula. Let's just look at a couple of examples of making use of that formula. So really the key thing is being able to identify in your equation what's A and what's B and what's C. So make sure that your equation's written in the right order, everything's on the one side, all the like terms are collected before you get going. So here we have A is 2, B is 3 and C is 1. Also be careful of negatives, make sure you don't miss negative signs. So our solution here will be x equals negative b, so that's negative 3, plus or minus the square root of b squared, which is 9, minus 4 times a, which is 2, and times c, which is 1, all over 2a, so 2 times 2. So we're going to have negative 3 plus or minus the square root of 9 minus 8, all over 4. So that's negative 3 plus or minus the square root of 1, all over 4. So we can work out the square root of 1. So we have negative 3 plus or minus 1 all over 4. So we could have negative 3 plus 1, which is negative 2 over 4, or negative 3 minus 1, which is negative 4 over 4. So we get negative 1/2 or negative 1 are the solutions here. Now the fact that we got nice rational solutions here that don't involve surds actually means that we could have solved this equation by factorization and null factor law. So that would be something I would always check if I'm trying to solve a quadratic. Can I solve it by rearrangement? If not, can I factorize it? If not, then use the quadratic formula. Okay, another example. So here we have now be careful here because our terms aren't in order. So actually, if we rewrite this first, x squared plus 4x minus 2. So now we can see that a is 1, b is 4, and c is negative 2. So our solution, x will equal negative b, so negative 4, plus or minus the square root of b squared, which is 16, minus 4 times a, which is 1, and times c, which is negative 2, all divided by 2a. So we're going to have negative 4 plus or minus the square root of 16 plus 8 all over 2. So negative 4 plus or minus the square root of 24. Now that third isn't in simplest form, so I'm going to simplify that first. So 24 is the same as 4 times 6, which means that this is square root of 4 times square root of 6, so 2 times the square root of 6 over 2. And now once I've simplified that third, I now have a common factor of 2 here. So I can divide both the numerator and denominator by 2 and get negative 2 plus or minus the square root of 6. Alright, in the third example here, we have a equals 4, b equals negative 12, and c equals 9. So our solutions, x equals negative b, so negative 12 will be positive 12, plus or minus the square root of b squared, which is 144, minus 4 times 9, so that's 4 times a times c, all over 2 times a, so 2 times 4. So 12 plus or minus the square root of 144 minus, now 4 times 4 is 16, and 16 times 9 is also 144. So we have 12 plus or minus the square root of 0, and the square root of 0 is 0. And so we get 3 on 2. So only one solution to this quadratic equation, and that solution is 3 on 2. And you'll see that we got the one solution because of the fact that we got 0 underneath the square root. So our two solutions come from that plus and minus in the quadratic formula, and by having plus and minus 0, it means we don't have two solutions, we only have one solution. And we'll talk a bit more about that expression underneath the square root and how we can determine whether or not a quadratic equation will have solutions, one solution, two solutions, or no solutions. Okay, and the final example, it's all in order here. So A is 4, B is -6, and C is 3. So our quadratic formula, x is equal to -b, so -6, which is 6, plus or minus the square root of b squared, so 36, minus 4 times a, which is 4, and times c, which is 3, all over 2 times a, so 2 times 4. So 6 plus or minus the square root of 36 minus, so 4 times 4 is 16, and 3 16s are 48. So 36 minus 48 is -12. And here we have a problem because we can't take the square root of a negative. So actually, this quadratic equation has no solution. So again, you'll see that no solutions arose because of what's going on underneath the square root. The fact that we have a negative value underneath the square root means that we won't have any solutions for this quadratic equation. And we'll talk more about that in the next video on the discriminant.